Hello, welcome back for lipids this time. We have, again, you should have your reading guide out. We do number 6, 7, and 8 this time. And we'll also fill out that next section of your macromolecule chart. So you should be on the second row. You should put in this organic molecule lipids. And here we go. So lipids are a very diverse group of hydrophobic molecules. That is an important quality. I would include hydrophobic as far maybe underneath where you wrote lipids or in the function part, right? Something about that they are hydrophobic because that's a very important part of a lipid. They are one class of large biological molecule that does not consist of polymers, actually. So that's a unique quality for lipids. They do have some molecules, but we would not consider them really a polymer. One thing about their elements, they do have carbon, hydrogen, and oxygen. So the same as what we had for carbohydrates. However, the ratio is very different. They have a lot of carbon and hydrogen and very, very little oxygen. Okay, so if I gave you like a structural formula and asked you to determine what macromolecule this is, when you notice that it only has carbon, hydrogen, and oxygen, okay, you should be able to get it down to carbon or carbohydrates and lipids. And then to determine between those two, you would try to look at, well, does it have pretty much equal carbon and oxygen? If it does, that would be more carbohydrates. And if there's very little oxygen, then you would probably determine that it is a lipid. So then they share a common trait of being hydrophobic, and that's really because of those hydrocarbons. Okay, so here we have a picture. This is called a triglyceride, tri meaning three, right? So 1, 2, 3. And they are connected by what we would call a glycerol. And this oxygen portion here would be the glycerol portion. So what I would like you to write down for the monomer of a lipid, you should write down fatty acids and glycerols. So there's 3 fatty acids and a glycerol for each fat molecule. And again, you see that below. There's 2 types of smaller molecules. A single glycerol is usually 3 fatty acids. They can vary in length and number, and also the locations of a double bond, and I'll get into that in a little bit here. But so this is what a glycerol would look like, and then your hydrocarbons would come off of that. So they can, again, vary in the length and the number and the locations of double bonds. And those double bonds, if we look here at this top fatty acid, it is completely what we would say saturated with hydrogen, meaning it has as much hydrogen as possible. So that's for this one right here, has as much hydrogen as possible. So we would say that this one is saturated. Whereas these two, they contain here and here, also here, a double bond. And that double bond prevents it from being saturated. We would say they are unsaturated. Okay? Unsaturated. And what that also does is it kind of creates this kink. So notice it kind of kinks it. Whereas this one is more of a straight line. Okay, and that is also characteristic of saturated and unsaturated. So the saturated is more of a straight line, and the kinked ones are more unsaturated. And that's just due to the double bond again. All right, get my mouse back here. All right, so this is just again a review. Saturated fatty acids, they have as much hydrogen, the maximum number of hydrogen possible. They have no double bond, and you see that classic straight line. No kinks in there. But these are also usually solid at room temperature, such as butter. Then if we look at saturated, they're more liquid at room temperature. So olive oil, canola oil, vegetable oil would be examples of this. And again, you see that kinked structure, and this is be your location of your double bond. Okay, so then because that double bond, there's not as many hydrogens as possible, creating that kinked. So we would call that unsaturated. Phospholipids, another really good example of a lipid. They have two fatty acid tails, and then they have a phosphate heads. Okay, so that's again a phospholipid. This is what creates cell membranes, creates that water barrier that we talked about in chapter 3. So again, now what makes this a little bit unique as far as these go, we have a hydrophilic head, hydrophilic meaning water loving, and then we have this portion down here, which is hydrophobic, and that's what creates that water barrier. So this is the lipid component, and this is the phosphate component, which you can see there. And that, again, allows it to create that water barrier. Very important. Good example. Very important example of a lipid, this phospholipid. So if we look here, this would be like a cross section of a cell membrane. And again, we have those phosphate heads interacting with water. They would be hydrophilic, versus in here, this would be your hydrophobic lipid tails, and they do not interact. This is the portion that is creating that water barrier. But we have to have those phosphates because cells do have to live in water, and they have to be able to interact with water. All right, steroids are another example of a lipid. So you could write down that for another example. They're usually composed of ring structure. An example of a steroid would be a cholesterol, and that would also be found in cell membranes. It allows the cell membrane to keep its fluidity. And that's it for lipids. So just to review, hopefully you got all these columns down, but I know I go a little bit fast. So for the monomer, you should have something about fatty acids and a glycerol, or a triglyceride would be 3 fatty acids and a glycerol. For elements, you have carbon, oxygen, and hydrogen again, but we have a lot more carbon and hydrogen than oxygen, very little oxygen. Examples, you could say fats, oils, waxes. You could have maybe saturated and unsaturated fats there. Cholesterol and steroids were other examples. Now, didn't really talk a ton about the function of a lipid, but if we look at the function, it's chief. If you think about what fat does in your body, it stores energy. So it provides a lot of energy. It also can act as an insulator. So those would be some good functions. That kind of wraps up lipids.